Hello, I'm Karan Joshi, and this is my first video on descriptive data science. And this is the first time I'm making a YouTube video where I am speaking about anything to do with data, computers, or any educational stuff. And if the response for this video is good, I will make more of these. So let's get started. So first, I assume that the people watching this video are having some knowledge of Python, the programming language, and I am here using the IPython console on my computer. I'm using a 2016 MacBook Pro, and over that, I'm using this tool on the command line. IPython is a command line tool which helps you set up command line interfaces for Python very quickly. So let's get started with the data set. So first of all, let's load the data. Let's import Python. So I have written some piece of code already here on how to import Python, and our data set, it is about cars and second-hand cars and different attributes of second-hand cars and how they are priced, basically based on those attributes. So this is the path of the data set. Other path, which is written as other path. You can also give a local path to this function. Now, a local path would be something which is inside your computer already. This is a URL which pulls the data from the internet. So, uh, first I'm importing pandas as PD. Uh, I'm just importing the pandas package and naming it PD so that I can use it again as PD, which you can see after df I've written pd.read csv here. pd.read csv, other path, and headers equals to none. So this headers equals to none has a very interesting story. We will come to that in the later part of the video. First, let's get started with just loading this data frame, and let's just see how that data frame looks. So I press enter. The computer pulls data frame from the internet, takes some time. Now I want to see how the data frame looks. So I want to do a df dot head, open parenthesis, close parenthesis. This shows me the first 5 elements by default. Now, if you want to see more elements, if you want to see uh, 10 elements, 20 elements, 30 elements, what you can do is you can just pass it as an argument inside the parenthesis. So let's do that. So df head, I will put in 20 here. So it will show me the first 20 elements. So the way to find out if the elements are 20 or not, let's just do a len function on this. So the length is 20. So now we are confirmed that this function does what it is supposed to do. It's supposed to show us first 10 or 20 or by default 5 elements. Um, and it is doing its work correctly. Now here, as you can see in the data set, uh, there is in the first column there is no column names. All right, for each column there is, in the first row there are no column names, there are numbers. So this is kind of puzzling for us, and this has to do with something I did here, where I passed data frame pandas underscore CSV with a headers equals to none argument. Now let's see, just copy this function over and just see if we do that without none, what happens then. So let's copy this and paste it here, and then just close the parenthesis. All right. And now let's look at df.head. Now you can see that the first column of each element is also the column name for the whole line of elements. For example, Alfa Romero is representing all the cars. So we clearly know that Alfa Romero does not represent all the class or the class. I mean, all the cars are not all the cars are not Alfa Romero. So it is something which is a mistake, and from this we found out that our data is not labeled, and that means that we have to label it manually. So now the way to do that is to first remove these labels. We will just again load the data with headers equals to none argument. There, now let's just check how does the data look now. Yep, there are numbers rather than column names. And now what we should do, we should just pass a list uh, with the with argument to the argument df dot columns. Now I have already created this list, and mm, actually I found it somewhere in the internet. So I will just put that list equal to df dot columns. Now first let's see what uh, this list has. So I have saved this list as headers. I'll click. So this tells me all the attributes that are there, uh, which are to be passed in columns. Okay, so now let's just do a little passing of the functions to the data frame dot columns equals to headers. And now if I check df dot head, the columns have the column names rather have magically appeared. Now I can see what things means what, and what things there are in the data set. And just to get a brief summary of the data set, I'll just do df dot describe, enter. uh, this tells me there are 205 rows and 26 columns in this data set. And actually, I've done a mistake here. I did not use the parentheses. Yeah, so this is the right function. It just showed me the whole data set uh, described without uh, the parentheses. So it gives me a count, it gives me a mean, a standard deviation, a minima, a 25% quartile deviation, a 50% quartile deviation, and a 75% quartile deviation, and a maxima. So all these things we don't need to worry so much about right now. We just here are doing data cleaning. So all these things come into play when you do more deep descriptive data analysis, and basically when you really look into the data from a standpoint of finding out things that you need to answer your question. Now, the question we are looking to answer here is, let me see, what can we find out with this data? Um, let's find out the correlation between horsepower and what else is there? RPM, peak RPM and horsepower. Now, peak RPM is different than general, like, average RPM. Peak RPM means what is the maximum revolutions that the wheel of this car can take in a minute in relation to the RPM in general, average RPM, which means that what is its average on a day-to-day use, what's the revolution of its wheels in a minute. So let's do that. Let's look at horsepower and peak RPM. Let me just pass them into variables very quickly. So HP is equal to df open square bracket, and now we need to put in the name of the attribute that we are looking at. uh, Here we are looking at horsepower. Now if I do horsepower, it tells me what's the length, uh, and it generally gives me a vector, uh, which I have pulled from A to C. Actually, exactly not a vector, but it's sort of a vector. The labelings are there, 0, 1, 2, 3, 4, so can't really call it a vector. But if you single it out, you pass it into a numpy list, or a numpy array rather, it will be a vector then, in the true sense. So vectors are very useful. Vectors are very useful for machine learning, and we will see how those are used while we are doing machine learning and while we are using TensorFlow. So for now, we have just separated this attribute from the rest of the data set, and now we will do a cut on the RPM. So let me name this variable RPM equals to um, same thing here, df. So now let's look at RPM, and this is the general data set that we have. So now moving on, there is a Python library called matplotlib, which is generally very, very useful for generating plots for data. So let's import matplotlib. We've imported matplotlib.pyplot as plt. So pyplot is generally where all the functions which generate plots live. So it's kind of a shortcut. You don't have to type matplotlib dot pyplot all the time you want to generate a plot. So let's look at, so what I want to generate here is a scatter plot. So let's plt dot scatter hp comma rpm. So here you have to notice what it means to pass the first argument and the second argument, and what sequence you need to be mindful about what sequence you pass the arguments in, because if you want something on the x-axis, you always want to pass that as the first argument in any of these libraries. So yeah, we have done that. Just close the parenthesis, enter. Okay, so there is a problem. Uh, could not convert string to float, and there is a question mark somewhere in the dataset. Okay, so now I have seen this data before, and I came across this problem, and the solution that I found was this. So we will use something which is a general pandas function, which is called replace. Now what replace does is it replaces something with something else. So here what strategy we are going to apply to get rid of these question marks is that we are going to replace them with none. So now this function always works with lists. So you have to work with lists on these functions, and so here we have done a rpm replace question mark rpm replace with none. So we have parsed two lists inside the function. Then we try to do this and apply this onto our data set. We press enter. uh, we have to do the same for horsepower, HP. We do that. Now we do a scatter plot. So when we click, there is no problem. Let me pass it into a variable so that Python can remember this. And now let's do a plt dot show, which is generally a function that is used to see the scatter plot. Now I should see the scatter plot in a moment or so. Okay, Yeah, here it is. So the scatter plot is here. Now, looking at this scatter plot, what we can see is that there are many values in somewhere in the vicinity of 4800 RPMs, which are giving different different x values. So now this gives us a sense of what is the trend regarding the RPM versus the horsepower. And here what we can see is that there are there are several horsepowers which are attributed to the same RPM. So this kind of tells us the half story. Now it'll be very interesting to plot brands into it, then do labels on this and make it a pretty graph. But all those things are out of the scope of this video. So we'll close this for now, and that's all for this video. Thank you.